we're going to be looking at a truck that's going up a muddy 30-degree incline. The mass of the truck is 3,000 kilograms. The coefficient of kinetic friction between mud and the tire is 0.158, and the truck starts from a standstill. The truck's final velocity is 1 meter per second, but on a 30-degree slope, so we need to multiply 1 meter per second by the unit vector for 30 degrees. The initial momentum is 0, and the final momentum of the truck is 2,598.08 in the x direction and 1,500 in the y direction. It takes the truck 75 seconds to go up the muddy hill. We are wondering what the force the engine exerts on the truck will be. First we start with the momentum principle. dp dt, our net force, is approximately equal to the change in p over the change in t. Therefore, our net force is 34.64 newtons in the x direction and 20 newtons in the y direction. The net force is also the sum of the force of gravity, the force of friction, the force of the engine, and the normal force. We can further break these down into their magnitude and directions, and split those into their x and y components. We take the magnitude of the gravitational force times its direction, plus the magnitude of the normal force times its direction, plus the magnitude of the frictional force times its direction, all in the x direction, and that to our variable, the force of the engine, in the x direction. This is all equal to our net force in the x direction of 34.64. Now we can solve for the force of the engine in the x direction and do the same thing we just did for the y direction. This will give us a vector of the force of the engine, which is 18,757.5 in the x direction, 6,281.45 in the y direction, and 0 newtons in the z direction.